This is the first question from the force mock test. A 467 gram glider rests on a frictionless surface, an air track, and a force of 2.1 newtons is exerted for 35 centimeters. What's the glider's acceleration and final velocity? So part A, I think what we want to do is just F equals ma, right? So A is going to equal F over m. Is going to be 2.1 newtons. And since it's frictionless, that's the only force acting on it, right? So I can just do, this is like a Newton's second law problem, divided by 0.467, right? And that's going to be approximately that is 4.4967 meters per second squared. I'm going to change my mode here. Okay, enter, clear. There we go. And then it says, what's the final velocity? And the final velocity is going to be one of these things, right? Our initial is presumably 0 because it's at rest. The acceleration is positive 4.4967, and x is 0.35. So you want to change this into 0.35 meters, right? You want to turn this into 0.467 kilograms, right? Those are the unit conversions. And then my formula that I would use is the VF squared, is VI squared. Apparently that's a popular one, right? Okay. And since this guy's 0, the final velocity is just going to be square root of 2ax, right? So it's going to be square root of 2 times 0.35. So times 2 times 0.35. And then I'm going to take the square root of that. Hey, there he is. And then this is not just this second. And then I'm getting that the final velocity is 1.77 meters per second. Ta-da. So that's part A. Part B says, what force would accelerate the glider from rest? And this is what the test question is going to be like. It's going to give you like a little kinematic question and ask you to figure out the force from that. And so the trick is you obviously find the acceleration first, multiply by the mass, you've got the force, right? So that's part B. If it goes from rest to 3.1, so 0 to 3.1 meters per second in 0.12 seconds, what's the force, right? So I'm just going to use VF is VI plus AT, because I just happen to know that's the one I want to use. And so the final is 3.1 equals 0 plus acceleration times 0.12. And then, of course, I just divide. The acceleration is going to be 3.1 divided by 0.12. 25.8333. Is that the right acceleration? Meters per second squared. And then to find the force, F equals ma. And since there's only one, there's no friction on this one, right? This is just like Newton's second law. I can just take this and go F equals 0.467 times 25.8. Right? So I'm just going to multiply this by the mass. Hopefully that'll give me the right answer. I'm lacking faith. 12.06 newtons. And that's the answer I get, yeah. We have a question. Matthew's got a question.
Is it 467 grams?
467 grams, yeah, that was a typo. I double checked all the answers. Didn't double check that apparently. Yeah, I'm moving right on to C. Is that okay? Okay, so I think B we're okay. And then C says, if there had been a force of 0.7 newtons opposing the 2.1 newton force, what would have been the final velocity, right? Assuming it's, this thing, and this force is now opposed, right? So for C, I think our diagram is like this. We've got 2.1 newtons this way and 0.7 this way, right? And then what do we do with those problems? It's a crazy subtraction thing, right? So we set up our F equals ma. Positive 2.1 minus 0.7 equals 0.467 a, and now we can find a. So 2.1 minus 0.7 is 0.14 probably, huh? 1.4. And then divided by 0.467. The acceleration is 2.99785 meters per second squared. Is that right? Yeah, you sure could. It wouldn't be a big difference, right? I'm just carrying all these digits because it's not polite to round too much when you're not done yet. And then we want to find the final velocity. And the way we did it here was we did square root of 2ax. We're using vf squared. Right, so the final velocity squared is 0 squared plus 2 times 2.99785 times 0.35. And then if I solve that for the final velocity, it's the square root of 2 times the answer that I just got times 0.35. And I get that it's 1.4486. The final velocity is 1.4486 meters per second. There's an answer, there's an answer. Are we okay on number 1? Yeah? Yeah, number 3. 3 is crazy. What? Should I do 3 next? I could do 3 next.